and welcome to Chemistry with Lisa. Here we simplify chemistry for you just to make you truly understand and upgrade your skills in chemistry. Today we have an exciting topic on chemical bonding, and at the end of this class there are a set of questions for you to answer to assess your level of comprehension. So make sure you watch this video to the end. Also, do well to subscribe to this channel if you find this video very helpful. Invite your friends to also do the same. Now, let's dive into what we have for today. Now, why do elements bond? Basically, elements bond for one major reason: in order to attain the duplet or octet state of stability. Elements bond for stability. So elements bond to attain the duplet or octet state for stability. Now we have different types of bonding. So number one is electrovalent or ionic bonding. Number two is covalent, coordinate covalent or dative, metallic bonding, hydrogen bonding, and van der Waals forces. So let's look at them individually. Okay, so let's look at electrovalent or ionic bonding. Now, this is a type of bond that exists between a metal and a non-metal. It is a type of bond that exists between a metal and a non-metal. So let's look at this. Between a metal, example of a metal, sodium, and a non-metal, example of a non-metal, chlorine. Now, sodium, the atomic number is 11. Chlorine, the atomic number is 17. If you don't know how to find the atomic number, I will also drop a link. I will drop a link in the comment section as well as in the description box so that you can watch the video that talks about elements, symbols, and the atomic number. Okay, so the atomic number of this sodium is 11, that of chlorine is 17. Now watch how we arrange it in shell. 1, 2. The first one usually contains 2 only. The other ones contain 8. 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 8 and it's filled up. 11. Now chlorine is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17. Now watch what is going to happen. Now this person, sodium, has 1 electron in the outermost shell. It will be easier for him, or it will be easier for sodium to give out this 1 electron than it will be for chlorine to give out its 7 electrons. True or false? True. So, in order for sodium to be stable, it will easily give out this 1 electron and become an ion. Remember, elements bond for stability. Until they bond, they cannot react. Until they bond, they cannot react. So, in order to be stable, it has to give out this 1 electron. Now, if we count this, it will be 1, 2, 2, 1, 2, 3, 4, 5, 6, 7, 8. 8 and 1. Let's count this. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. So, when they bond, what will be the resulting effect? Now, this electron is transferred to this person. So, once it is transferred, it has moved to this chlorine. So, this shell is no longer needed. This shell is no longer needed. So, the electron has gone to chlorine. Now, this sodium has moved from 281 to 28. And chlorine has moved from 287 to 288 because of the additional electron here. Are we together? So this is what we refer to as what? Ionic bonding. This is what we refer to as ionic bonding. There must be a transfer of electron from a metal to a non-metal. This is ionic bonding. Okay, so let's look at the properties of electrovalent or ionic bonding. Number one is that they have high boiling and melting points. Why? It is basically because the electrostatic force between the molecules are very strong. So it is going to require a lot of energy to break them. Hence, it has high boiling and melting points. The second one is that they are good electrolytes. What is an electrolyte? Any substance that conducts electricity in liquid or molten form. Any substance that conducts electricity in liquid or molten form is what we refer to as electrolytes. So, ionic bonding are good electrolytes. They can conduct electricity in solution or in liquid or in molten form. Then solubility, they are good soluble, highly soluble, especially in polar solvents like water. Now, other examples of ionic bonding include acid sodium chloride, you also have potassium chloride, you also have magnesium chloride, you have sodium oxide, you have potassium oxide, you have magnesium oxide, and so on. It must be a metal and a non-metal. Now let's move to this next type of bonding. Okay, so we look at covalent bonding. Covalent bonding, in covalent bonding, there is a sharing of electrons. Unlike in electrovalent, one gives another. In covalent, they don't give, they share. They collaborate. There is a sharing of electrons between the two atoms. And it usually occurs between non-metals. Covalent bonding occurs between non-metals. So let's look at this hydrogen molecule. Let's look at hydrogen molecule. Hydrogen, the atomic number is 1. Let's draw it. 1. Then hydrogen molecule, they are now 2. So another one, 1. They are unstable as they are. In order for them to be stable, remember they must attain duplet 2 or octet 8 for stability. They must be 2 or 8 for them to be stable. So in order to be stable here, what do? They come together and share. They come together and collaborate in order for them to be stable, because one cannot give out. If one gives out, it will no longer exist. So what they do is that they come together. When they come together, this person is coming with its electron and this person is also coming with its electron. As you can see, both of them now have 2. Remember, for them to be stable, they must have either 2 or 8 in their outermost shell. So what is it here? 2. 1, 2. So they are stable. This is what we refer to as covalent bonding. Okay, so these are the properties of covalent bonding. Number one is that they have low boiling and melting points. Because the electrostatic force between them is weak, you have less energy to apply to them in order for them to attain their boiling or their melting points. However, there is an exception to that, like the family of carbon, diamond has high boiling points. There are exceptions to this, but a majority of them, they have low boiling and melting points because the electrostatic force between them is small or is low. Then they are non-electrolytes. Remember, electrolytes conduct electricity in solution, molten or liquid form. So these substances under this covalent bonding, they are non-electrolytes. Then solubility, they are not soluble in polar solvents. Rather, they dissolve readily in non-polar solvents. Non-polar solvents like benzene. Unlike ionic bonding that dissolves in polar solvent like water, these ones they don't dissolve in polar solvents, they dissolve in non-polar solvents. Example, benzene. Now, other examples of covalent bonding include chlorine, you have ammonia, you have oxygen, hydrogen, etc. So remember, it must be between two non-metals. Okay, so this is coordinate covalent or dative. Here, one atom donates to other participants. Unlike in covalent where there is sharing, here one person is the philanthropy given to the other people. Let's look at this. Example is ammonium, ammonium ion. Now, you have that nitrogen is the lone pair here, surrounded by hydrogen. Are we together? This is ammonium ion. We have another example, tetramine copper 2 ion, copper 2 ion. Now, you observe that many of them are in ion. Most coordinate covalents or dative are usually in ion. So, copper 2 tetramine is written like this, tetramine copper 2 ion. So, you discover that this is shared by ammonia. Tetramine silver 1 ion. You have tetramine silver 1 ion. Tetramine silver 1 ion. You also have hexacyanoferrate 6 ion. Hexacyanoferrate 6 ion. All these, now a good number of them, almost all of them are ionized. All these, this is also ionized, minus. So all these, 1, 2, tetramine silver 1 ion, potassium hexacyanoferrate 6 ion, tetramine copper 2 ion, ammonium ion. Most of the coordinate covalent or dative are usually ion. That is why they form complex ions. So they are coordinate covalent or dative bonding. Let's move to the other type of bonding. Then the next type of bond is metallic bonding. This is a type of bond that exists in metals. They exist in metals. Metallic bonding. And example of those bonding are bonding that exist in metals like sodium atom, aluminum atom, magnesium atom, calcium atom. Those bonds that exist in metal we refer to either as metallic bonding. Hydrogen bonding, this is a type of bonding where hydrogen reacts with highly electronegative elements. Hydrogen reacts with highly electronegative elements. Example of highly electronegative elements include oxygen, fluorine, chlorine, iodine. Hydrogen reacting with highly electronegative elements, we refer to it as hydrogen bonding. Usually in hydrogen bonding, there is what we refer to as dipole. Dipole is where hydrogen is partially positive and the highly electronegative element is partially negative. So example of hydrogen bonding is hydrogen fluoride. Hydrogen is partially positive and fluorine is partially negative. There is a drop while hydrogen is drawing, chlorine or fluorine or the highly electronegative element is also drawing. Therefore, or thereby bringing a dipole status. So, examples of hydrogen bonding include hydrogen fluoride, water, hydrogen chloride, hydrogen iodide. Remember, hydrogen bonding is between hydrogen and highly electronegative elements. Then the last type of bonding is the van der Waals forces. This is the weakest type of bond. It is the weakest type of bond, and it exists in discrete molecules. It exists in discrete molecules. It is very weak, extremely weak. So, and it exists in discrete molecules. Examples include naphthalene, iodine, ammonium chloride. Now, these van der Waals forces exist in those substances that move from solid states to gaseous states without passing through the liquid phase. So, how can something move from solid to gas? That means the intermolecular forces are very weak, so that at the slightest pressure, you will discover that they will do what? They will break. The bond holding them will break, and the molecules will move into the air. So, van der Waals force is the weakest type of force, and it exists in discrete molecules. These are the examples where it occurs. Now, let's move over to the questions. These questions were called from the past questions of the previous year's exams. So, number one says the major reason why chemical reaction occur among elements is that they have tendency to attain the duplet or octet state for stability. What is the main reason why elements react? They react to attain the duplet or octet state of stability. Then number two, in electrovalency, valency electrons are transferred and the atomic number is. Now, what do we refer to as valency electrons? Valency electrons, remember in electrovalency, those electrons are the outermost shell. Remember, electrovalency, it is between a metal and a non-metal. So those electrons that the metal give out and the one where the non-metal receive, those are referred to as what? Valency electrons. The electrons are the outermost shell. They are referred to as the valency electrons. So when they transfer the electron or when they receive the electron, what happens to the atomic number? Let me give you a good example. Let's say sodium now reacting with chlorine. When they give the electrons, what happens to the atomic number of this person? Now, the atomic number is not affected. Remember, it is valency electrons we are looking at. What happens to the atomic number? The atomic number is unaffected. The only person that is affected is the electrons. The electrons are affected, but the atomic number, that is the proton number, is unaffected. So, what's the answer to this? Unaffected. The atomic number is unaffected. What is affected is the number of electrons. So you discover that at the end of the day, the number of electrons here, because the person becomes plus, the number of electrons here will now be 28, while the number of electrons here will now be 281. The atomic number or the proton number is not affected. The neutron is not affected. The only person affected is the electron moving around the shell. Number three, the bond between two iodine molecules is. What is the bond between two iodine molecules? Iodine. What type of bond exists in iodine? Van der Waals. Van der Waals forces exist in iodine. Remember what van der Waals forces is? It exists in elements that are weak. It is the weakest. Van der Waals is the weakest type of bond. The bond type between copper 2 ion and water molecules. Remember what I told you? In most cases, when you see ion, what are you looking at? Coordinate covalent. Remember, examples of coordinate covalent include you have your ammonium ion, you have your tetramine copper 2 ion, you have your, and most of those things that have ion, once you hear ion, know that you're talking about what? Coordinate covalent. So copper 2 ion, to write this, it will be copper 2 tetrazo. Sorry. So the answer is what? Coordinate covalent or dative. Once you hear ion, what comes to your mind? Coordinate covalent or dative. Then the bond type in a diatomic nitrogen gas is, so you ask yourself, what is nitrogen? Nitrogen, this is diatomic. Diatomic means that it has two atoms. Please make sure you watch the video that I put in the description box or in the comment section, because I've explained everything about diatomic, all those things. In fact, some of the things here, we've explained it there in detail. So make sure you watch that video. So diatomic nitrogen gas, this is nitrogen, and this is a type of bond that exists between what? Two non-metals. So for you to have this, it will be nitrogen plus nitrogen. That will give you diatomic nitrogen. So this is a non-metal, this is a non-metal, and what will be the answer? Covalent bond. Covalent bond. Now I have a question for you to answer. Okay, so what type of bond exists in calcium chloride? I want you to drop your answer in the comment section. And also, what type of bond exists in graphite? Drop your answer in the comment section. All right, we've come to the end of this class today. Please do well to subscribe to our channel and invite your friends to do the same. Thank you very much for watching. Success in your exams. Bye.